from plastic Omnium lighting. There's a long list of career, not only depending on his own career, but the reason that Osram was part of some companies and not part, and so on. So I will shorten up it a little bit. Michael worked 11 years for Osram as strategy and head of product development for automotive laser systems. Then, due to different changes of Osram in the advanced development, optics development, and now his new position at Plastic Omnium is the leading innovation of newly created lighting division, compromising the former AMS Osram and Baroque lighting system to a new combined level. Michael, the stage is yours.
Thank you very much for the kind introduction. As you see, we had to change the presentation to a real video and actually excluded another photograph topics. I'm really happy to be here and present to you our view on digital projection, so on what is the freedom that comes with it actually for you as OEM, for the tier ones, for all the tech suppliers. And I'd just like to give you a bit of a guideline actually, what is to take care of actually in terms of technology, in terms of the use cases, and I would like to guide you through that. So for sure the automotive megatrends you're well aware of, they are influencing the development of automotive lighting and projection systems. So we see that advanced infotainment systems are happening. Basically now it's exiting the light, the content is exiting from the four corners of a display onto surfaces. You may have seen it in the concept study of the BMW Mini Aceman actually, that now projection on the dashboard is extensively used actually as extension of the display. We see new vehicle designs due to the advent of electric vehicle, or they are already here. New concept languages, new design languages are possible with that, because the grille is going away and light is exiting the four corners and entering the front and rear fascias. And of course the digitalization is happening. So basically we bring new content over the complete car lifetime to the end users. This is updated, this is also influencing the lighting community. And digital projection, as the word says it, supports this trend for sure. So I think what is important to mention, to look, as the colleagues before showed it, to look at the use cases on the one hand side, but also look at the technology. So what is possible to do? So on the one hand side, you have use cases projecting in the near field, projecting in front of the car whilst driving, for design purposes, for information purposes, but also the technology, and find this right balance in how much euros and dollars you're going to spend for it, and what technology is necessary to include actually to drive this purpose. And this can be, for example, simple static projection, symbols, graphical elements. This can be dynamic features, so you have a movement that actually catches your attention, but not likely to be digital. And you have digital projection really with freely updatable content, while on the one hand side from the OEM, but on the other hand side also maybe from the end user side. This can be done monochromatically, this can be done in color, depending on what the regulation is allowing. So as said before, what do we see today? So today we have ground field projection around the car as kind of welcome and leaving home applications. We have dynamic projections as the newly introduced BMW 7 Series is showing with MLA technology. We have DMD projections in front of the car in white, and of course the capability of updating this over the air to drive here new features. What do we see tomorrow? Signal light projection, so basically a safety increase. So this is currently being discussed in the regulatory bodies to do a product proposal. So what is making actually the traffic more safe? What is not distractive? And really to optimize here on the one hand side the projection size, but also the daytime visibility aspect. For sure it has to work, a safety aspect actually whilst driving under certain conditions. And one of the examples can be, as the picture shows, a turn indicator projection. And this is currently not allowed for sure, but it's work in progress. And looking at the future and what might be possible, like here for sure, in that case, it seems a bit distractive actually, but to show within automated or autonomous driving modes the intention of the car and warn or inform actually other traffic participants on the intention and the actions of the vehicle. There will be for sure, with the advent of that, new lighting functions to increase here the safety, and that's all what we are working on, and we should come up with useful proposals actually to drive that. So very basically on the module design, as you all know, this incorporates the strong interaction of optomechanics, electronics in one housing. In the middle you see the optical light engine. I will then zoom actually a bit more into that. So around it is, of course, if you talk about digital projection in the near field, where you need resolution, a DMD plus electronics, mechanical interface parts. You fold around an electronics concept in that sense that you can reduce packaging size and can create a very small module to be integrated in different installation spaces. And for sure, we do not want fans and so on, a passive cooling concept where I come then later on what actually is then the guideline for that application that you have to look for in terms of driving that. And we can reach up to 25% for the whole system market, for the whole system efficiency, with roughly a maximum of 150 lumen, comprising now 0.2 or 0.3 DMD sizes. For the optimization, zooming back into the module itself, for sure this term of module efficiency versus complexity displays an important role in the system design. So what do you want to achieve in the end with the module that you are developing, and basically is integrated then, and there are three main topologies and architectures to be used. Typically one actually well known from office projector, the prism design, where you have a prism actually folding the light into the projection, onto the DMD and then into the projection lens set. For sure this has the highest efficiency in terms of system. So with like roughly this 25%, you have very homogeneous DMD illumination with this concept, but on the other hand, you have quite some elements in compared to the other ones in terms of cost. Also, this would be the one actually that for sure you have advantages, but you also have disadvantages. In terms of the field lens design, you reduce already here the number of components. That's very beneficial. You get a slightly reduced system efficiency. You potentially have ghosts. You have to take care of ghost imaging on the projection plane due to the reflection on the field lens. It's slightly more difficult to assembly, but you save components and therefore costs. So, and it reduces, as it is also written, it reduces the system flexibility, but because in the end you want to create a platform with that, and you use it in different applications throughout the vehicle, and with that it's more difficult actually to change, for example, projection lens sets, and then to achieve other aspect ratios in terms of the projection area. And the last one, the right side, is the freeform mirror design. It's definitely the most complex, the most compact design, well known also from front lighting. You reduce further the concept, the number of optical elements within this concept. You have a bit of poorer homogeneity, but that also depends then on the use case. You are not projecting on a white wall, you're projecting on the ground, you're projecting on interior surfaces, cloth and leather, and this might be good enough. So in the end, that is something, some trade-off you have to take into consideration, a bit of lower optical efficiency, but you actually have a very compact form for that. So just to give you an impression, now zooming into more even into the projection lens set. So depending on the installation situation of the DMD in relation to the projection area, you will get a certain tilt of the DMD versus the projection plane. And if you have that, for sure you do not have equidistant pixel sizes. In the end, you have different sized elements now to project on, which makes it necessary actually to pre-distort the video or pre-distort the image, because the end user is not interested to see a distorted image. He wants to see the image actually he is supposed to see on the floor. But out of a certain projection angle, you will have some distortions, and therefore you pre-distort. This can be fixed a bit manually or optomechanically. In fact, that you go now, you look at the orientation of the DMD chip. If it's based on the installation space a bit tilted, You can now correct it by setting an offset of the P-lens or the projection lens, therefore shifting a bit the ground projection area, but at least then creating more homogeneous pixel sizes of same sized elements, which then makes the pre-distortion actually less necessary, therefore creating a better image quality. So, in coming to the thermal topic that I mentioned initially, so this is, you have to imagine now this work or this flow of the end consumer stepping into the car. So he's welcomed by the car, by a welcome scenario. On the outside, he's looking at light, blinking and flashing, and then he opens up the door. He gets drawn into the car, and basically what is then possible and what we investigated is to have a module that is set to 100%. You have a continuous mode, 100% light output, but to a certain extent to design it in a way that you do a certain power mode, you overdrive actually the module for this first initial reaction, you get pulled into the car, you sit in the car, and actually to a certain extent, maybe 30 seconds, we investigated that you could overdrive it, thermally okay, and then you go into a transient phase where the eye is actually not really recognizing that you dim down the light, but still you see the same illustration, orchestration of the light, and then you step into this continuous mode, which is then maybe on during driving, just as functionalization of surfaces. If you now want to use it for warning, again, you could overdrive it to a certain extent. And I think that's the main message is that we need to think about the thermal application profile first in designing it, because it has in the end a very big impact on the module design itself. So whether it's then an actively cooled or passively cooled, what heatsink size to design for, it's mainly depending on that. Just quickly switch back. No. Sorry. So on the electronics architecture, just to give you this rough overview of what we are talking about. So in general, we start always with the light source, the optical engine, so to speak. So we start with the LED, the light source, the illumination parts, folding the light onto the DMD under the certain acceptance ratio, acceptance angle, then designing an application-specific projection part. Everything is assembled to a so-called light engine. Then in parallel you start by assembling the front board electronics, folding around the light engine in terms of power electronics, communication electronics, to do the DMD driver management and electronics and the software which drives the whole thing. And to integrate this into a dynamic projector, you have to take care of course, of the mechanical assembly of the housing, the thermal management as said. And then you have four very important characteristics. On the one hand side, the design is mainly driven on what surface you're projecting on, under which conditions. The mechanical interface, meaning where to install it. Is it the rocker panel? Is it the side mirror? Is it on the interior, the overhead console? Or some pillars, A or B pillars, to be mounted to? Do you want to have flexibility in terms of adjustment? That is very important to consider in the module design. And for the EE architecture, for sure, it's a digital projector. So in the end, you need to make sure that it's updatable, you can move and create new content on that. And there are different architectures to use, and it has to fit in terms of boardnet architecture on the car to be included. And of course, on top of it, the light function itself. So are these restored video data, is it live stream? That needs to be considered. And typically, two illustrations of the use cases that you would have. So you have central ECUs, and on the one hand side, if you go for live streaming, you for sure have the power to drive those modules. You have a communication line, and you have, for example, LVDS, GMSL for live video data streaming, but it's currently one of the processes for headlamps. On the other hand, you have an update suitable system where you have a CAN or an Ethernet interface and the power to the module, and then you update it via the download actually via the central ECU and create new content from time to time actually for the end user. So both systems are connectable over the air, but a difference actually in the electronics architecture. And for sure there are different solutions how to do that. As you might be well aware of, if you look for the 0.3 and from TI, you look at the DLPC120, which is live stream capable. You connect this via LVDS or Ethernet time-based T1S, so allowing actually a simple communication on that. You would not need memory, so actually this is the topic to take care of. We have fully validated here in RGB or in a white module actually to be included. We are doing tests with that in terms of installation in different spaces and what actually can still be sacrificed in order to reach low costs. And the other topic is to update video content over the air. There are two main architectures to do it. Today, the one is with an FPGA. So basically we store the data and the binary on that. We drive it with a typical controller used in automotive lighting, and the update is also done via Ethernet. So very simple connection protocol via the different actuators. Or we use the newer version actually now of TI, which is called Vitara actually, which is one controller, which does the job basically, and there is no limitation in terms of memory driving that. So in the end, it's an evaluation, both of those systems. We can support here the OEMs actually in doing test scenarios. What is the best possible installation option for defined use cases from the OEMs? So that is something we are happy to do with you together. So, and that's the overview of the modules we have used for tests and for the installation. So we have we have two solutions with ultra compact installation sizes, for sure with very low lumen output, it's 50 lumen roughly, but good enough for certain applications. So that's something that needs to be discussed together. What is the right application for that? The performance modules, which reaches up to roughly 100 lumen actually for exterior projection into different installation spaces, and the performance module, for example, for interior roof projection, where we place the projector within an installation space in the interior to project really on the sunroof and creating their graphical elements and videos actually to orchestrate lighting on the interior. So, and just to give you a bit of an outlook actually how this could look like if you're orchestrating this around the car from the topic of individualization up to the topic of safety. We included here a little video actually to show how this could look like. So what you see here would be a 270-degree welcome installation. Basically you move up to the car. If you're backing up, for example, here out of a parking lot, a dynamic rear projection according to the steering wheel to change actually also the projection on the ground. You would also see that in the rear view camera, exactly in that plane actually, which is illustrated if you're parking in. That would be something that is quite helpful. Also in interaction with sensors, so you detect okay how far away you are. If you're backing out now of a parking space where you have a bad visibility, to include that it's earlier visible for pedestrians and traffic participants. Also this advanced turn indicator to really highlight okay, the intention of the vehicle and to make it early visible. So, this brings me actually to the end of our presentation. I think with this potential that in the end all of the data and all of the experience that we've made so far over the last years actually in terms of digital projection, this is changing and it's necessary actually to do updates over the whole lifetime of such a module, of such vehicles. That's necessary to bring that in, and digital projection is the way to do it. It's not a hardware-bound module that is built in. It's updatable by the OEM or it's opened up to the end consumer, so therefore this will change automotive lighting towards a higher customer centricity to include here really the end user in the chain of the decision, and eventually increase also the road safety. That's necessary to regulate, that's necessary to discuss. But I think with digital projection, I think we are free to do and to drive that. I think that's a good message. So just to summarize and to follow up on, so tomorrow as it was introduced by Hector, we have the keynote speech from Plastic Omnium from our CEO Laurent Favre. Please check out also by my new colleague now, Rainer Neumann, the presentation on the low profile ADB headlamp system. That's also very interesting to hear. And please visit us at our booth here on this floor. Actually, check out the lighting modules that we have. And thank you for your attention.